Uh, Dear students, welcome to the SLMC 13 training. So today we are going through the 30 questions of SLMC 2021. So first I'll go through the easy questions. So something to be reminded. So you can score uh, 5 points per one question in the AC section, and 6 points per one question in the medium section, and 8 points per one question in the hard section. So let's start with the questions from the AC section. Normally, uh, it's expected, like if you are going to the second round, usually it's expected to do all the 10 questions from this easy set. So let's start with the first question. So here we have we measure two arithmetic progressions, and we ask the um, ratio between the first term and the common difference. So let's say first term is A and common difference is D. So this is the easiest question here. So in order to arrive at the ratio, we have to use this information here. So there are two main information. So sum of the first 10 terms, and then again you have the sum of the first 5 terms. So we can write two equations to the sum of the first 10 terms and sum of the first 5 terms. So remember the sum of terms in an arithmetic progression. So it's 10 divided by 2 into 2a plus 9d. So this is the sum of 10, and you have sum of 5 divided by 2, 2a plus 4d, and you know that the ratio between these two equal to 4. Now let's see how we are going to find out the last ratio. 2 into 2a plus 9d equals 4 into plus 4d. So 4a plus 18d equals 8a plus 16d. So you can see that we arrive at the ratio 2d equals 4a, a divided by d equals 2 divided by 4, 1 to 2. I think we have arrived at the answer. Yeah, this is easy. So if you can do the algebraic simplification fast, you can arrive at the answer very quickly. So let's see the second question. Consider squares a and b that have drawn on infinite grid above. So these wordings are important. Infinite grid, and area of A is 16 units and area of B is 2 units. So A and B, area of A and B. So these are examples. These does not is not a part of a part of the question, but they are just examples to see how the area is calculated. So area of A is 16 units because the length is 4 units and the length of a side is 4 units. And in case of B, you can see that there are two points, and the distance between these 2 points is √2, and the area is square of √2. So the question asks is, what is the area of the square which cannot be drawn on the grid? That means you have to find the number from these 5 which cannot be a number representing an area in the grid, or area of a square drawn in the grid. So how can we arrive at that? So we need to find a property. We need to find a property of areas drawn in the grid. So what is the property? The main property is, let's say we have any point x1, y1 when we consider the length of a side. So we have x1, y1 here, and let's say we have x2, y2 here. So you can derive that the area of the square is x2 minus x1 squared plus y2 minus y1 squared. Since this is an infinite grid, you can have arbitrary numbers for x2, x1, y2, y1. So you can see the property is the area should be a sum of 2 perfect squares. So this is the property. By using this property, you can evaluate each of these numbers whether these numbers are sum of perfect squares. So let's say like 5 can be written as 1 plus 4, which are sum of perfect squares. 61 can be written 36 plus 25, sum of squares. 10 can be written 1 plus 9, sum of squares. 89 can be written, how is 89? 64 plus 25, sum of squares. So these are just two digit numbers. If you're going to check it, you can just start with any square. Like for example, if 89, you can subtract 1 perfect square and see whether the resulting number is a perfect square, and you can iteratively do this for all the other perfect squares, so that you will arrive at a sum of perfect squares. If you do not arrive at a sum of perfect squares, that means it is not a square that can be drawn in this particular grid. So you can see all A, B, D, E can be drawn as perfect squares, but C cannot be. So you don't even have to check the numbers for 15, but if you really need the perfect squares greater than less than 15 are 1, 4, 9. So you can see 15 minus 1 is 14, which is not a perfect square. 15 minus 4, 11, not a perfect square. 15 minus 9, 6, not a perfect square. So you can see that 15 is the answer. Yeah, so far so good. So main point is, like when we are going to find something which does not satisfy a property, we first need to find that property. Like it is just about the area of a square, but we need to find what are the properties of this particular number. So then when you observe carefully, you can find this property. Okay, now third question. What is the largest integer that is a divisor of n plus 1, n plus 3, n plus 5, plus 7, plus 9 for any positive integer n? So again, let's see for any positive integer n. So this is very important. So that means this should be satisfied for all the positive integers, not just one. If you find at least one positive integer n that uh, cannot be divided by a number, that means that number is not a divisor. So here we can use some observation skills. Suppose n plus 1 is an odd number. When n plus 1 is an odd number, you can see all others are odd numbers. All others are odd. Now all others are odd. What does that mean? That means 2 is not a divisor. 2 is not a divisor. That means 2 does not generally divide this product. If 2 does not generally divide this product, any multiple of 2 do not divide this. That means 2 does not divide, 32 does not divide, 36 does not divide. Now we just have to see whether like 15 is the answer. So we can start from 15 because 15 is the largest. So we are asking for the largest number. Now we just have to see there are consecutive terms in an arithmetic progression. And since there are 5 numbers, we can always find a number here which is divisible by 5. So that can be n plus 1, that can be n plus 3, that can be n plus 5. A number, so there is a number. So you can see all these are different numbers. So exactly one of these numbers is a multiple of 5. That means the product is a multiple of 5. Similarly, we can see that there are consecutive you can find consecutive 3 terms in an arithmetic progression. That means the product is also a multiple of 3 for any n. So if the product is multiple of 5 and if a product is multiple of 3, and you know that 5 and 3 are co-prime, that means they don't have common factors. That means product is a multiple of 5 into 3, 50. So that is how arrive at the answer. Okay, question number 4. positive integers a, b, c, d are such that ab plus bc plus cd plus da equal 20. What is the maximum possible value for a plus b plus c plus d? Now, when you see that, so these are positive integers. When you see this equation, you should observe that this equation can be factorized. You can see b into a plus c plus d into a plus c plus 20. A plus c into b plus d plus 20. Now, the problem can be reduced. Find in the factors, because we know that these are positive integers, so we just have to find the positive factors, and you can find different values for a plus c and b plus d. Such that and x plus plus x2 is maximum. So you have to start with the largest factors. So the largest factors are 20 into 1. So this means x1 equals 20 without loss of generality, x2 equals 1. But we need to do some validation, because you know that a, b, c, d are positive integers. So what happens if x2 is 1? That means b plus d is 1. B plus d is 1. If b and d are positive integers, the minimum value for b plus d is 2. But here b plus d plus d equals x2 equals 1, which is a contradiction. That means x1 plus 20, x2 equals 1 is not an answer. Right. Now let's try the next set of factors. So next set of factors is 1010. 2. Now here also we need to do the valuation. X1 is a possible value, 1010, and x2 is also a possible value, because we can choose b equals 1 equals 1. 1010, for 1010 also we can find any set of a and b which satisfy this. For example, we can say a equals 505, c equals 505. It doesn't matter, but we are looking at the summation, maximum summation. Now we can see that x1 and x2 are valid answers. So our maximum sum is x1 plus x2 plus 1012 is an answer. Right. So we are done with 4 questions. Let us go to the 5th question. What is the unit digit of the number? So you have a summation. So you can see each even number, each cube of the even number is subtracted, or a minus sign is in front, and you need the unit digit number. Here also you need to make an observation, because in all these questions you have many terms, but if you are going to use brute force and to compute the actual summation, you don't have time. But what you have to do is find a pattern and generalize it and use some formula for that. For example, in this case, you can see the pattern because we are asking about the unit digit. If you consider the numbers from 1 to the terms from 1 to 10, the unit digits is always like 1 cube, 2 cube, 3 cube, and so on, and finally 0 cube. Can you observe that when it starts from 11 also, the unit digits, the unit digits of these numbers are equal. I mean, the unit digit of the cube of 11 is equal to the unit digit of the cube of 1 because, let me show you. So cube of 11 is 10 plus 1's cube. So this becomes something like 10 to the power 3 plus 3 into 10. You can see that except the last term, which is the cube of the last digit, all other terms are divisible by 10. That means this reduces. The unit digit of cube of 11 reduces to the unit digit of 1. So you can see the same happens for unit digit of 12 to the power 3 as well, because we can write it as like any number, the last digit, I mean unit digit of x cube is the unit digit of cube of last digit of x. Now you can see for each of these 10 terms, you have the same set of unit digits. Now that is the first observation. Observation 1. 𝐿HK 10K, let's say these terms. Okay, in other words, unit digit of T 10K plus R is constant for any K. So it is easy for you because you don't have to write all these abstractions, all these proofs. When you have the intuition, you can find the answer. But since I'm going to explain this precisely, I'm writing all this stuff. But you don't have to write all this. You just have to find the intuition. So you can see that unit digit of this summation, it says, and unit digit of this summation is also S. And you can see that unit digit of the full summation full summation is how many s you have, right? You have 1 to 10, 11 to 20, and finally 2011 to 2020, and finally you have 2021. So these are the terms. So if you see the number of terms, you have to divide. You find it in chunks of 10 until 2020 divided by 10, 202. So you get s into 202. So you just need to find the unit digit of s and multiply it by 202 and add 1, because you have to consider the unit digit of the last term as well, 2021 term. And then you will have an interesting observation. You can see you start with considering the unit digit of each set of numbers, and we found how many sets are there, how many such sums are there, and we found that there are 220. Now we have to find the unit digit of this sum, unit digit of this sum. So unit digit calculation is all about finding mod 10, finding the remainder when you divide by 10. So here, now let's see what we can do. If you observe very carefully, you can see that any of these summations can be grouped. You can see 1 and 10. Okay. 1 and 9. 1 and 9 can be grouped. 2 and 8 can be grouped. So you can group everything except the 5. Except the 5. So you remain with cube of 5. The unit digit of cube of 5 is still 5. And you have the unit digit of 10 to the power 3, which is 0. And when you see these 1 and 9 combined, you have 1 cube into 9 cube. And you can see there's a factor, 1 plus 9. The factor is 10. And when you consider 2 and 8 also, there are minus signs, but they have the same sign. So here also we have minus 2 plus 8 factor. Now you should be able to figure out that this summation has a factor of 10. 10 into something. 10 into something plus 5. Plus 5. Plus 5. And what you just have to do is, that is, the unit digit of s is 5. And unit digit of this 202 into s is, the unit digit of 202 is 2. Unit digit of s is 5. 2 into 5. So 2 into 5 is 10. That means unit digit is 0. But you have to consider the other one as well. So the unit digit becomes 1. So let's recap it. So you started with this summation, and we grouped this summation to a similar set of summations, uh, different summations of each having 10 numbers, and we found out that each summation, the unit digit is same, because only the last digit matters when it comes to mod 10. And then we figured out how many such summations are there. There are 202 summations, and then after all this, you have the last term as well, last term, unit digit of the last term as well. And then we were going to figure out the unit digit of one summation, and we considered the pairings between the numbers in this summation. So we paired them such that each pair, the base number of each pair sums up to 10, so that the 10 becomes a common factor, but 5 was left out. And then we found the unit digit of 5 to the power 3 as 5, and then we figured out that this is the unit digit of s, which is 5. So we substituted 5 here, and this is the multiplication or product. So the unit digit of this product is 2 into 5, which is 10, that means 0. But we have remaining 1. 1 is remaining from the last term. So the unit digit is 1. The point is that if you are going to write a proof, it takes a long time, but you are allocated just like 3 minutes for this question. So it's all about intuition. Like you don't have to write the proof, but in the intuition you should find that the pattern. Like there's a repetition of the unit digit between these summations, and how many such summations are there, and within each summation how to group the numbers so that you efficiently find uh, the unit digit. So there are several things you have to come up with, but this is the way of thinking. Right. Now let's go to the sixth question. So this is a logic question. So you can see there are five friends eating a big cake, and one other friend, so he's left out. So he saw that his part is also being eaten. Now he asks from each one about the status of the cake, the piece of cake, and it is given that each one says exactly one truth and exactly one lie. So here, if you are going to analyze all these sentences, now it's not the way. It takes a lot of time. But one easy hack is, now you can see there are different kinds of questions. So for example, Sarath says it wasn't Peter and it was Abdul. And for example, let's say it was Abdul is the truth and it wasn't Peter is the lie. But can you see what happens? In this case, it happens to be that two people have eaten it, because the what is given is only one person have eaten it. Let's see if it was Abdul. So you can just start by assuming one is true, and then let's see, we have to see whether these assumptions are consistent. If they are not consistent, the assumptions are wrong. That means we have to assume the negation. So that's how we approach the logic problems. But in order to make it efficient, we should know where to start. But here, let's see, we start with what Sarath says. If we see that if it was Abdul is true, and if it wasn't Peter is false, then what happens is, so Abdul has eaten, according to the true statement, and according to the false statement, Peter also has eaten. So this cannot happen. So that means it was Abdul. It was Abdul's statement. Statement is false. It was Abdul's statement is false. So it's not Abdul. And it wasn't Peter. It wasn't Peter. Peter is true. But now, can you see what happens? If you have two negated statements, what happens is you can shortlist now who has eaten, because it is not Abdul and it is not Peter. And we have three more left. So our suspicious people, the set of suspicious people, happens to be a set of three people. When we start with uh, two sentences which gave negated, like one says it was, one says it wasn't. I can say, so this is not a best way to start. But like if you have the intuition, the best way to start is start with two sentences which provides the same sentiment, like either a positive sentiment or a negative sentiment. That means either say it was someone in the both statements, or say it wasn't someone in the both statements. In that case, you know that exactly one is true. Exactly one is true. Uh, that means you and exactly one is true, and that means you find two people, like your set of suspicion, your set of possible answers becomes smaller. So let's say so in the first case, this is just for illustration. Yes, if we start from Sarath, we have to do uh, several deductions, which gives us the possible set as Meena, Sarath, and Kamala, which is a larger set. But if you start from what Kamala says, Kamala says it was Meena, it was Abdul. So you know exactly one of these two, Meena or Abdul, Meena or Abdullah in the set. One of these should have it. And when you compare with the Sarath's case, if you really need to see it, you can see Abdul is not a possible candidate for eating the cake from this. So Meena is the only one who are in both sets. So you can conclude that Meena is the one who ate. But this is not the only path. You can consider other statements as well. Uh, for example, Abdul's statement also you can consider. So finally, you can arrive at the answer Meena. So like this is the strategy is consider the statements and find a list of candidates, which can be the answer. And from each statement, you can find the list of candidates, and the correct answer should be consistent with all the lists. That means the correct answer is the intersection of all the lists. So here, like, we don't have to consider all the lists. Even by considering two lists and the intersection is just one answer, that answer should be the one. Okay, now question 7. Consider the sequence where n term is defined as an equals n squared for natural number n. So it starts with n equals 1. So that's the sequence. So square numbers, you can see these are the perfect squares. So you have to consider the three statements. So first statement, there is a term in above sequence which is divisible by 2021 into 2022. So here also, when they say there exists a term, there are two ways. Either we have to prove that there's a term exists by using some theorems, but also we can find that particular term. So here they are saying that there is a perfect square. There is a perfect square which is divisible by, or where 2021 and 2022 is a factor. So easily we can say that when you have two factors, you can find the square of these two factors. So square of a number is divisible by itself. You can see 2021 into 2022 divides 2021 square into 2022 square, which is in the sequence. That means the first statement is true. The statement is true. Now let's consider the second statement. There exist two consecutive terms in the above sequence which both are divisible by 3. Now let's consider the modular arithmetic. So how the modular arithmetic works for the square numbers. So square numbers can be like any natural number can be written as 3k plus 1, 3k minus 1. And in the sequence, it's like you have 3k minus 1, 3k plus 1. So you can see that any two consecutive natural numbers have different numbers modulo 3. So they can't be both divisible by 3. They can't be both divisible by 3. Any natural number. So let's compare the squares of them. So square 3. Since minus 1 squares to be plus 1, this modulo class will be 3k plus 1. 3k plus 1. You can see squares of natural numbers forms a sequence of modulo 3 to be 3k plus 1, 3k. So it's an alternative sequence. So there are no two consecutive numbers which are both divisible by 3. That means second statement is false. Now let's see the third statement. There exist two odd terms in the above sequence whose sum is Now let's consider the last statement. There exists two odd terms in the above sequence whose sum is divisible by 4. Now again we have to consider modulo 4. So at the first place we consider modulo 3. Now let's consider modulo 4. So in a similar way to modulo 3, you can find that uh, any odd square number is 4k plus 1. If you just need to prove it, so you have 4k plus 1, 4k plus 2, 4k plus 3 as the natural numbers. The squares become 4k, 4k plus 1, again 4k plus 4, that means again 4k, 4k plus 3 is 3, the square of 3 is 9, 9 is again 4k plus 1. You can see any odd square number is 4k plus 1. So that means sum of any odd squares is 4k plus 1 plus 4k plus 1. That is like 2 mod 4. In other words, like 4k plus 2. So that means it becomes 4k plus 2. So 4k plus 2 is not divisible by 4. That means there's a remainder of 2 when you divide by 4. That means third statement is also incorrect. That means only correct statement is 1. So the answer is 1 only. Now let's go to the question 8. So the question 8 also you have a very long product, but here we need to find some simplification. So by experience, I can see like you can try to find some telescopic product. Telescopic means that you cancel out the terms, the nearby terms. So it just repeatedly happens. So in this case, let's say now we have 1 over 1 minus 1 over n squared, and we have 1 minus 1 over n plus 1 squared, and so on. And if you write these, the first term becomes n squared minus 1 over n squared plus n plus 1, n minus 1 over n squared. And when you write the n plus 1 term, that becomes n plus 1 square minus 1. It means n plus 2 into n. You see that, you can find that 1 n can be cancelled out. 1 n can be cancelled out here. And if you write it in a specific way, you can see you have star of 2. So 2 plus 1, 2 minus 1. 2 minus 1 is 1 into 3. And 3 minus 1 is 2. 3 plus 1 is 4. We have 4 minus 1 is 3. 4 plus 1 is 5. And you can write the last terms as well. 2021 square and 2020, 2022. Before that, 2020 square, 2019, 20, 21. Now if you see that, like let's just consider the 3 square. So 1 3 is simplified with the previous term and another 3 simplified with the next term. I can see this happens for all the terms except few, except for few. So 2020 squared is also 2019, 2021 is cancelled out. So if you like write this is how this cancels. You can see here this 2 is left out. And this 2022 is left out. And 1 of 2021 is left out. So this becomes 2022 to 2021. Simplify 1011. Answer. So let's consider it again. So for each square term, there is a similar term in the left side and the right side. So these are cancelled out. And we just need to find the last 2 terms, because like the starting term and the final term. So in the starting term, there's no one to cancel out. Like this cancels out from only one side. And here also this happens. Like 2022 does not cancel out. And 2021 cancels out from only one side. So that means we have 2021 remaining, 2022 remaining, we have 2 remaining. So this is the telescopic product. So the final answer is 1011 divided by 2021. Okay, now this question. P is a polynomial such that Px equals this product for all real x. Real x. So this is important. It means x can be positive, negative, 0, anything. How many integers n satisfies Pn squared equals 0? Okay, like forget about n squared. This Px becomes 0 if x equal to any of these numbers. So x can be 1, x can be 2, x can be 3, and x can be 20, 21, and also x can be -1, x can be -2, and so on. X can be minus 20, 21. These are the roots of x values. Now, here the question is Pn squared. That means x should be in the form of n squared. So x should be a perfect square. So we first check the roots of Px. And here roots of Px such that x equals n squared. Right. Now we have reduced the question. Now we have to find what are the set of like how many perfect squares are between these set of numbers. How many perfect squares are there? So 2021, you can see that 2025 is the square of 45. So from 1 to 2021, there are 44 perfect squares. Okay, so is the answer 44? No. We are going to find how many integers n satisfied. How many integers n? So we have found the number of possible values for n squared equals 44. But number of possible n's for 44 n squared values, we should consider the minus root as well, right? So that means it becomes 44 into 2. And you can also see that the 0 is not a root. So thus we don't need to avoid double countings. So we can just multiply by 2, because all of these are non-zero squares. So we can consider the negative n value also. So you have 44 possible n squared values and 44 into 2 possible n values. So this is very tricky. Like this can seem like a very easy question, but if you miss this how many integers part, you may write 44 as an answer. So it's better to read very well, like whether it's a real, whether they ask for real number, whether they ask for rational number, whether they ask for integer, whether they ask for positive integer. So you have to be very careful. Okay, final question out of the easy questions. Okay, there are no positive integers a, b, c that satisfies this equation. How many pairs of rational numbers? Okay, so when you see the questions, this question, you have to use this information that there are no positive integers. So positive integer is also important information here. There are no positive integers, and here the information is about positive integers, but the question is about rational numbers. But we know some relationship between rational numbers and positive integers. A rational number can be represented as a ratio between two integers. That means it can be positive, it can be negative, but there's a clear relationship. Now, in order to make use of ABC, can we do something like this? So x can be a divided by c, y can be b divided by c. Is this always the case? Not according to the main definition, but we can prove this will be the case. Now let's say x is, according to the rational number definition, x is p1 divided by q1 and y is p2 divided by q2. And can we consider the common denominator? If you consider the common denominator, q1, q2, p1, q2 plus p2, q2. P to Q1. Now this is just x plus y. Now can we see that x can be written as P1 Q2 divided by Q1 Q2. Y can be written as P2 Q1 divided by Q1 Q2. That means for any x and y, we can find three positive integers a, b, c, not necessarily positive, three integers a, b, c, such that uh, x and y can be represented as, so here now is a, right. Now we have found a way to reduce this xy equation with a, b, c. Okay, but now we have to find different cases because still a, b, c are positive integers. Positive integers. Okay, but now for the moment let's think that a, b, c can be any integer where c is non-negative. C is non-zero. So we can write uh, okay. Now ABC can be positive, negative. Like C is non-zero, and we know that when ABC are positive integers, there are no solutions. That means if there is any solution, uh, at least one of them should be non-positive. That means zero or negative. So let's consider the case of zero. If one of them is zero, if one of them is zero, uh, either A is zero or B is zero. That means either x equals 0 or y equals 0. That means, let's say without loss of generality, if x equals 0, that means y equals 1 by considering the equation. If x equals 0, y is 1. So that means 0 and 1 is a solution, and by changing x and y, 1 and 0 is also a solution. So we have found two solutions. But what about negative ones? What about negative ones? So there's a small thing we can do. We can rearrange this a ABC equation. because if there is a negative number, the other one should be positive. Like if y is negative, then x should be positive. So that means in other words, uh, so this has no positive integer solutions. Let's say minus b equals d. This does not have a solution with one variable negative. So if two variables are negative, obviously there's no solution. That means there is no solution for when one of these is negative, and when one of these is 0, there are two solutions, and then when both of these are positive, there are no solutions. That follows through the first condition. Yes. So the answer is 2. There are two solutions. Okay. So that ends the discussion for the easy questions. So let's meet again with the medium questions.